Good day, Injury and Total No Asina. My name is SamuelLingSuYiew. Today I'm going to present my FYP with the title of Prediction of Vibration Response of Heritage Building at Muar Johor due to the seismic activity from the Sumatra zone. At first, the seismic activity that originates from the Sumatra zone may have the possibility to affect the building in our country because the Sumatra zone is near to our country and it is classified as the high seismicity region. And in the problem statement, Malaysia is classified as the low seismicity region. Therefore, the seismic impact is usually not considered in the building design, in the conservation and the preservation of the heritage building. So the objective of my FYP of this study is to identify the vibration response of the heritage building due to the seismic impact from the Sumatra zone and to determine the structural capability of that heritage building to resist the seismic load. Literature review. Response spectral analysis is chosen to use, which it was the technical for estimating the peak structural response of a structure under various natural frequency. And interstory moisture and the seismic pressure was the product of the seismic analysis. So, and there are two important information should be provided. So, which firstly is the seismic data and second is the soil profile. So first seismic data, and here show the peak ground acceleration record from year 2004 and to 2010. So in this data, I'm choosing the data on 2005, which the peak ground acceleration is equal to 1.75, and according to the design ground acceleration equation, which is peak ground acceleration multiplied with the importance factor, so we can know that the design ground acceleration is equal to 0.02 meter per second squared. So the importance factor is equal to 1.2 for the government facility. And for the soil profile is provided by the Malaysia Highway Authority that are conducted in 1989. So according to the soil profile, you can see that the most of the soil is the same loose to medium cohesionless soil. So in according to the Unicode Act, the ground type classification, so we can know that the soil Muar is classified as the ground type D, and it was consists of a loose to medium cohesionless soil. And these are the important equations in calculating the seismic pressure. And now until the methodology part. So this show the flow chart of this study. So you can see that there are two software are applied. So one is ST, one is another is StatFlow. The heritage building I chose is Old Telecom Building 1, and it was the colonial building of the Second World War, and it consists of the main building and also the sub building. The site investigation is conducted on 14 March 2020, and we are in this site investigation, we are measuring the dimension of the building and also the structural elements such as slab, column, and the beam. After collecting the data, we are proceed to the modeling process. So, ST software is chosen to output the structural key plan of the old telecom building, since it's more familiar and easy to be used. And these are the structural key plan that output by the ST software: ground floor plan, first floor roof plan, first floor plan, and the roof floor plan. And now proceed to the analysis process. So StatFlow software was used to conduct the response spectral analysis, and this video shows the 3D visualization of the old telecom building more. And in the log definition part, though, there are 4 types of log: seismic log, dead log, and the live log, and the response spectrum log. And in the seismic parameter, we are applying the UBC 1997, which are the Uniform Building Code 1997. So all this important information we can be referring to the Uniform Building Code. And now until the response spectrum setting, so we are using the EC Eurocode app, and the design ground acceleration author in the literature review is 0.2, and the behavior factor is 3 for the reinforced concrete. Subsoil classes is type D, and log type is elastic response spectrum. Type 2 is for the magnitude with for an earthquake with magnitude more than 5.5. So, and this response spectrum is only applied in the S and Z direction, not in the Y direction. So this is the summary of the log and definition part. So you can see that only the dead log is assigned in the seismic log and the response spectrum log, and all this type of log should be applied as positive value. So, and until now proceed to the result and discussion. So you can see that these are the result of the mock share, and in the analysis process we cut the mock share into 10 parts. So we can obtain 10 mock share, and you can see that as the mock share increases, the higher the frequency, the lower the natural period. So but in identify the vibration response of the structure, the most important part is the mock share 1. So we can, for this, and this is the mock share data of the mock share 1. So you can see that it was the natural frequency of 2.753 Hz and the transitional in S direction, S axis direction. So the first mock share usually owns the lowest natural frequency. That is mean that the lowest frequency that usually experienced that will occurs as the building is experienced by the seismic activity. So these are the vibrations of the structure, and I just go to move for these are the mock shape with the different natural frequency. And now I'll proceed to the interstory drift test. So interstory drift test we are setting to the allowable drift to 0.01% since the interstory drift ratio is usually 1 to 2% of the ultimate emitter state. So as the result show that you can know that for all the level of the structure is passes the interstory drift test. So you can say that, and we can say that the building can reduce the seismic damage to the non-structural elements. And now proceed to the seismic pressure value calculation. So we should calculate for the dead load and the live load, and we can proceed to the seismic pressure. So I just go to, and seismic pressure calculation can be achieved by according to this equation, which is the seismic load combination is equal to GK plus 0.2 QK. So we can get the seismic mass for each levels. And this equation are you applied according to the imported equation in the illustrational view. So as the quanta is type D, and so we use the data, and after calculating the natural period, so we can know that it is between the TB and the TC. So we use the equation 2 in the literature review, and we can calculate for the seismic pressure, which is equal to 340 tons, and the net horizontal force is equal to 20% of total building weight. And the pressure value can be for each level can be calculated according to this equation. So we can get the lateral force for each level, and 1 ton is equal to 9.81 kN. So after getting the seismic pressure, so we should check the accuracy of the data. So the difference between the manual calculation and the simulation result. So we can know that the first is the manual calculation result, and second is the simulation result. So from the total pressure, we can know that the difference between the simulation result and the manual calculation result is 1%. So we can say that the result is accurate and acceptable. And for the now proceed to the structural capability. So according to the clause 3.1.4.2 prestige standard, so the structures to be able to resist a notional horizontal load applied at each level equal to 1.5% of the characteristic dead load. So we should know that the total and here we are using the characteristic dead load, which the GK. So mid height above is the roof plane to the first floor plane, and the mid height below is the ground floor plane to the first floor roof plane. So we can get both of these logs should be multiplied with the 1.5%. So we can get this answer. So you know that the backstream value is greater than the total national log. So in conclusion, by conducting the seismic response analysis, so we can know that the vibration response and the structural capability of the building. And for the objective one, we know that the natural frequency for the mock share of the old telecom building is 2.753 Hz, which represents the lowest natural frequency experienced by the building. And through the interstory drift test, we can know that the structure is able to transmit less seismic vibration to the non-structural element, which lead to reducing the seismic damage on them. And for the second objective is to determine the structural capability. So we can know that the difference between the simulation result and the manual calculation result is only 1% difference. So the pressure value is exceed the total national horizontal load, which is greater than the 1.5% of the characteristic dead load. So we can know that the old telecom building one will experience such structural damage during seismic activity. So in conclusion, the seismic impact from the other countries should also be considered in the building design, in the conservation and the preservation work. That's all of my presentation. Thank you.